This is the second video of the topic function, and we are going to start with the classification of function. Actually, the classification of anything depends on the parameters. On the basis of those parameters, having those parameters, we can classify anything. Here, having certain class basis or parameter, we are classifying a function, and this function is classified in two groups. One is called injective function, and this injective function is traditionally known as 1 1 function. So traditional name of this injective function is 1 1 function, and nowadays it is termed as injective function. So we start with this injective function as it is written here. Injective function, and its old name or traditional name is 1 1. As the name suggests, this is 1 to 1 pairing. If a function is such that in which we are getting 1 to 1 pairing, 1 to 1 pairing means, as we know, for being a function, each element of the first set that is domain, each element of the first set that is domain must be paired uniquely with the elements of the second set, and this is called domain, and this one is called codomain. So this is domain of the function named f, and this is codomain of the function f. And if all the elements are uniquely paired with the elements of b, then we say that this function is, this relation or this association is a function. And now if we are having one characteristic added to this, that is the elements are 1 to 1 paired. That means if elements of a are taken as 1 to 3 and elements of b are taken as 1 a b c d, suppose that, and if they are paired such a way, then this kind of function is known as 1 to 1 function. That means injective function. That means under the head of injective function, we are to check only this, whether each element of domain are having different images or not. As for example, if we take a situation like this: 1 2 3 a b c d, a, and this one is set b. Suppose that a rule g is associating the elements of a to b, and suppose that this 1 is paired with a, this 2 is again paired with a, and this 3 is paired with b. First of all, we should think about, is this a function? Yes, it is a function, because this is fulfilling both the criteria. That the first one, all the elements of set A are paired, so the first criteria is fulfilled. And the second criteria was this: no no two no two such pairs of any element of the first set, that means domain, will be there. As for example, 1 is paired with only one element, 2 is paired with only one element, 3 is paired with only one element. So these three elements are paired, and these three elements are paired with only one element. So they are not having two pairs to them. So this is a function, no doubt about it. And now think about, here we find that the output of one to which we say image, the output of 1 is a. Again, the output of 2 is also a. Output of 3 is different, that is b. But mind it, in this one, however 1 and 2 are having unique images, are having unique outputs, unique images, unique outputs under the function f. Sorry, under the function g. Under the function g. So under the function g, however 1 and 2 are uniquely paired, but both are paired with the same element. With the same element. So we cannot conclude that, we cannot say that all the elements of first set, all the elements of domain are having different images. We cannot conclude that different images of domain are having different images. Different elements of domain are having different images. We cannot conclude that. And if it happens, then we say that this is not a one-one function. This is not a one-one function. So this is called non-injective, non-injective, non-injective function. That means you can say to this one, many to one pairing is there, many to one pairing is there, two elements are paired with one element, so many to one paired. So sometimes it is also known as many to one pairing, many to one function. Okay, this is traditional name, this one is traditional name, this is the latest naming system, and this is clearly, as you have here, this is clearly a one-one function. This is a one-one function. One-one. This is having one-one correspondence. So as this one is called one-one function, and nowadays it is termed as injective. So this function is injective. So injective function is it means that there must be one-to-one correspondence. There must be one-to-one correspondence. Each element of the domain part, each element of domain must be paired uniquely, as we know, for being a function. But no two different elements of domain should be paired with one element, as is done here. If it is done, then it is called non-injective function, otherwise it will be injective function. So clearly injective and non-injective function is now, I think, clear to us. Non-injective or many to one function, as it is written here, is very easy to understand now. I hope none of you are amazed to see that a function may have such a situation. A function may have pairing of all the elements of domain with single element of codomain, and 1 2 3 are the elements of A, B, C, D are the elements of B, and if we are having a function like this in which the image of 1 is A, that means if 1 is input, then its output is A. It can also be written in this way, F1 is equal to A. So 1 is paired with A. Suppose that 2 is also paired with A. 2 is also paired with A, that means we can say that if 2 is equal to A, that means if we take 2 as an input, then its output is again A. Or you can say that image of 2 is A. If we take another pair like this, then this can also be written in this way, F3 is equal to A. Now think for a time, for a moment, that all the elements of A are paired. No element out of 1 to 3, no element is having more than one pair in this function, in this set, in this collection. So clearly it is a function. But here we are getting that all of them are having the same output. Same output. So sometimes it is known as constant functions. And with the diagram, arrow diagram, we can represent this one as 1, 2, 3. We had A, B, C, D, and this one is paired with A. That means image of 1 is A, image of 2 is also A, and image of 3 is also A. So this kind of situation, if we are having, then this is a function. Clearly, this is a function, but this function is many to one function. This is not one function. This is non-injective function. So it is non-injective function, or you can say this is many to one function, many one function. Is it clear? And now we want to test the injectivity. In the process of testing of injectivity, we are having one way of doing is this. This the test under the testing of injectivity. This is the first way. This is the process by which we will check any function, that is that function injective or not. For that purpose, we term this one as analytical method. Analytical method. Analytical method. That means by having the analysis, by analyzing the given facts, we come to the conclusion that the function is whether injective or not. What is the process? Under this, we say that if image of A is equal to image of B, if equal to image of B. Okay, if somebody says, or it is given to us that image of two elements of first set, image of A and image of B are equal, then if we come to the conclusion that A is equal to B, then it means that there is no violation of the condition that for being any function injective, for being any function 1 1, we need to have different images for different objects, different elements of the domain. So if different elements of domain are taken and we got that they are having different images, then we say that the function is 1 1 or injective function. But if we want to check in this way, then we are having this way of analyzing for the test of injectivity. Then what does it imply must be understood by us. It implies that if we take that any element A and another element B are having the same image, and we come to the result, it is possible that these two elements will have same image. It is possible only when A is equal to B. So if it happens, then we say that no two different elements of the first set, no different elements of domain are having the same image, and then we conclude that this is injective function. Another way to test the injectivity of a function is this. This is termed as contrapositive method, under which in the beginning we take two different elements. That means in the beginning we make sure ourselves that these two elements are different. And if we want to know the images of those different elements, and we come to the conclusion that their respective images are different, their respective elements images are different, then we conclude that for different elements we are having different images. That means this function is injective. So this is another way. First was this, हम लोगों ने शुरू में सपोज कर लिया था कि दो एलिमेंट्स हैं, दोनों एलिमेंट्स की इमेजेस सेम, and then we concluded that if the images of these two elements are equal, then we concluded that a is equal to b. That means if it implied that a is equal to b, that means no two different elements are having same image. This contrapositive is again a negative part of that one. We are having here that if A and B are not equal and their images are also not equal, if A and B are not equal and their images are also not equal, then we conclude that, then we say that no two different elements are having same image. That means different elements are having different images. Both these way of explanations are coming to the same conclusion. So these two are many a times used, but usually we will use to this way of handling the test of injectivity of any function. Sometimes we will use to this way also. Okay, and in this process, first of all I am taking an example so that it will be made very clear in front of you, and in the next video we will talk about the surjectivity of a function. That means another function, surjective function. Here again come to the point, we took an example and it is said that check injectivity of the function. So in this process, first of all, as I said earlier to you, that in this process, first of all, we suppose that two elements, suppose that the elements are x and y, and we are supposing that the images of x and y are equal. Here x and y are the members of the domain of f. Clearly x and y are the inputs, and inputs are to be taken from domain. So clearly x and y are members of domain of the function, and we suppose that fx is equal to fy. And now our duty is to check whether x is equal to y or not. X is equal to y or not. If x is equal to y, then we say that no two different elements will have the same image. If these two are equal, surely x is equal to y. If we say in this way, then we say that no different elements are having different images. So come to the point, if x is equal to fy, we say we put x here, then we got 2x minus 3 by 2x plus 3 is equal to fy. Fy means what? Put y or replace x by this y, then it will be equal to 2y minus 3 by 2x plus 3. Now go through the simplification process, multiply crossword. So if these two are multiplied, then we got 4xy. I am multiplying by this 2y to these two, minus 6y, and by this one 6x minus 9, and this is equal to, when we multiply this 2x plus 3 to this one, then we got 4xy minus 6x plus 6y minus 9. Clearly you are seeing here some terms are cancelled out, these are cancelled out, and we got a relation like this. here 6x and minus 6x. When this minus 6x is taken this side in the LHS part, then it becomes 12x, and this 6y if is taken to the right hand side, then we got 12y. So clearly we concluded that x is equal to y. So the conclusion is now this: x is equal to y. So clearly, if x is equal to y is concluded, if we took fx is equal to fy, if we took fx is equal to fy, that means we took images of x and y are equal, and we concluded that x is equal to y. That means we want to say that if images of x and y are equal implies that x is equal to y. That means no different elements are having the same image. Virtually x and y are the same element, so why their images are equal. So we concluded in this way, so why this function is now termed as injective function. In the following video we will talk about surjectivity, and later on collectively injectivity and surjectivity will be taken together in a single question. Okay, till then, have a nice day. Thank you.